Okay, so this little warm-up right here, we are going to save this for the next day. So just go ahead and jump over to page 48. Okay, so here's what's going on page 48. If you notice, we are going to have something in between the trig function and in between the angle variable. So these are going to be double angle identities. Remember, there is a 2 in front of the theta. It's a double angle. These formulas are going to be given to you on a test or a quiz, so don't worry about memorizing them. However, if you notice our little double angle identities here, there's only one for sine. That's the only thing that you see where sine has a double angle. So if we are working with something that has sine, then of course we want to be looking at this top value. The next one, we only have one for tangent. I'm going to keep this color coded just so they kind of stand out a little bit. And then you do have several for cosine. However, you have one for a cosine where it's in terms of cosine and sine, and if you notice, it's a minus there. We also have cosine where it's going to just be in terms of cosine. And then we're going to have one where it is just in terms of sine. So if you notice, it can be written several different ways. Cosine is going to be useful because we can write it in several different ways. One more thing before we begin. If you notice, each one of these properties has a plus sign or a minus sign. I guess they're all minuses, except the first one. So remember, this first one is a monomial. So as you're working through this stuff and you don't know what to do, just kind of look, is there a plus sign, is there a minus sign, because it's going to help you out. All right, one more thing we're going to talk about. Where you see this symbol, that is after the trig word. So we're definitely going to need to know that as we move forward. So let's go ahead and get comfortable with these expressions. You do have some helpful steps here. The first step is to factor if possible. And then step 2 is to match it to the identity. Okay, so as you look at the first one, we have 6 sine x cosine x. So the x value is the theta symbol in these identities. And if you notice, there is not a plus or a minus sign. So the only way I can really match it to an identity is this first one right here. Now, the thing about the identities, they have to match exactly. So if you notice, there's a 2 right there, but we have a 6. So how are we going to turn this 6 into a 2? We are going to factor. So let's factor out a 3, because 6 divided by 3 is 2. So let's factor out a 3. So 6 divided by 2, or 6 divided by 3 is what we want. So that's 2 sine x cosine x. And now if you notice, what is in parentheses matches this exactly. So now we're going to do substitution. So what we're going to do is we're going to use this other side of the equal sign and just drop it in those parentheses. So now it is going to be 3 times sine 2 theta, but in this problem, theta is x. And then, can we clean this up a little bit? We can distribute, guys. Remember, that's just a monomial. Those parentheses don't mean anything on a monomial. So the answer here to simplify this expression is 3 sine x. And I'm going to color code. I'm going to use this green marker to remind myself I use this identity. If you'd like to color code, if you got a bunch of markers in your pencil bag, you might want to do it because these are kind of brand new to us and we're only spending 1 day on it. All right, let's go ahead and take a look at number 2. All right, so number 2 has cosine, so I'm probably going to be focused on this side over here. I also notice that cosine is squared with a minus number, so a whole number here. So I'm going to focus on this identity right here because it kind of follows this format. Again, there is a 2 in front. We have a 6 in front, so we're going to force that to be a 2 by factoring out. So let's go ahead and factor out what would make that a 2. 6 divided by what is 2? A 3. So let's factor out a 3. 6 divided by 3 is 2. And then negative 3 divided by 3 is negative 1. Now, if you notice, this matches it perfectly, which is great. Now we're just going to substitute this side over here. So it's going to be 3 times cosine 2x. And remember, those parentheses don't mean too much because this is one term now that we've written this substitution. There's no plus or minus. So let's write 3 cosine 2x. And I use the one that I highlighted in orange. I'm just going to box my answer in orange just so it kind of helps kind of match which identity I used. Let's look at the next one. So I do see the word sine, but I'm not going to focus on this because it has a minus. So it's probably going to be one of these over here. I'm pretty sure it's going to be this bottom one over here because that's sine squared x, and so is that. So the first number starts with a 1, but this problem starts with a 4. So let's factor out the 4 and see what happens. So factoring out a 4, 4 divided by 4 is 1. Negative 8 divided by 4 is negative 2. All right, so if you notice, it matches this identity all the way. It matches it perfectly, so we're going to do substitution. So now I'm going to drop in the other side of the equal sign, which is cosine 2x. So this is 4 times cosine 2x. I don't really need the parentheses, so I'm going to drop them. And then that's going to be the final answer. And I'm just going to box that in yellow because that's what I matched it with. So that's part of using the identities. If you notice down here, they kind of change a little bit. On problem 4, I can't really match until I put it back together because if you notice, there's no single cosine and sine. Everything is squared where there's a plus or minus. So let's go ahead and FOIL this. Remember, this is a difference of 2 squares. So this is going to be cosine squared x minus sine squared x. And when we FOIL that, we get exactly this top trig property up here. So this just really simplifies into cosine 2x. And that's it. Just going to box that in blue because that is what it matched. All right, let's take a look at the next one. So very, very important. Number 5 is not like any of these other ones. So things are changing here. If you notice, this is the first time that we've had a number in front of the letter X. All of these other ones were just a single X. This has a number in front. 3x is the theta symbol. So remember that because things are going to change a little bit. All right, so I know there's no plus or minus. This is the only one that doesn't have a plus or minus with it. I am forced to use this identity. This starts with a 2. This doesn't start with a 2. Remember, you have to make it match. We have to force this to start with a 2. It has to look like this. It has to look like that. But this doesn't equal, I can't change the value of it, but look. What if I multiply this by a half? What's a half times 2? It's going to take you back to this. So again, you are going to have to factor stuff out that you don't really see initially. You just kind of have to be intuitive to make it match. So there wasn't a 2. I had to force it to be a 2. I factored out in 1/2 because when I distribute it back, boom, I get the original problem. So we factored out a half. And look, this matches. This is a 2, this is sine x, and this is cosine x. So let's do our substitution. Let's drop in this sine to theta. Now remember, sine to theta. What is theta in this problem? It's 3x. So we're going to clean up what's over here next to the word sine. This is 2 times 3. So what we're going to have is 1/2 sine 6x. So if you have two numbers together after the trig word, that's okay. You can multiply them. Just remember, you can never, ever, ever multiply a number after the trig word by a number in front of the trig word. No, no, no. But you can definitely multiply two numbers that are after the trig word. I'm going to box that in green because that's a property I used. All right, let's take a look at the next one. So this is in degrees. We're going to leave it in degrees. But again, if you notice, there's no plus or minus, so I'm forced to use this up here. One more time, there's no 2 in front. We have to force this to be a 2. Not a big deal. We'll just factor out 1/2. There we go. If I distributed this half, it'd take me right back to the problem. So this line of my work matches that printed problem completely. All right, let's go ahead and drop in our substitution here. So this is going to be 1/2 sine 2 theta. Sine 2 theta is 30 here. So what is our answer going to be? Our answer is going to be 1/2 sine 60 degrees. Okay, that's part 1.